You can just go on with it. I don't know why it's not working.
So it's in the reviews actually.
Okay.
2 hours.
Weird.
Half of it is
Yeah.
at least, right?
Yep.
So,
Okay, so we get
here is copy of the
Go ahead, go on there.
this guy. I'm gonna leave this. This is actually the test bench, so I'm gonna leave this guy up and work over here. Okay, so now we need to make a 16-bit adder, right? 16-bit adders are always good. So we go in here, new source, Verilog module, and we'll call this adder 16B.
New source for Verilog. 16.
Oh, this needs to be.
It's a lot of
Now,
same inputs and outputs.
well,
We
now
need to-
since there's 16 bits, we need them like this.
So it would be like a
16 to 0.
15 to 0.
15 to 0, of course. Be a 15 0. Be
And this is just FYI. This setup is the same ordering that they have when you do like something colon something else, like 15:0 or 0:15. That's what this is right here.
Okay, that's consistent.
Yep.
Oh, you just do it in MSB? Okay.
Oh, they did bus.
You don't do it on port name, right? The 15
No, you don't do an import name. You do it over here. If you do an import name, it will complain.
Hey Dave.
Yep.
You at the most significant bit and least significant bit of CO. How come you have zeros?
That's because I clicked bus and then unclicked it and it didn't realize.
Okay.
That's just a stupid little silenced thing.
Alright.
Yep. Okay, so we click next, finish, and it opens this guy up. So once again, we're at this point. Now, have you done are you done copying over the test bench? Do you need the test bench there anymore?
Well, that's fine. We'll
Okay.
just continue on.
CSSE are not supposed to be 15K.
Just throw out the
Just do
bus.
bus.
You're fine.
Okay,
Good.
so in order to call another module, what you have to do is
Oh, this is where copy over.
you have to, first of all, in order to call another module, what we have to do is we have to call the, we have to put in the module name. So adder 1B in this case.
Okay.
I'm glad someone pays attention.
Oh yeah, that's.
Okay. We put in adder 1B.
Oh,
I don't want
We put in a name for it. This is just like a class name, essentially, but instead it's a.
Okay.
You know how you would say like foo f equals new foo? This is adder 1B add 1 equals new adder 1B. Except we don't have new. And then inside the parentheses we put in our arguments. So for the inputs for this guy we'll have A0, B0, and carry-in.
I think I'm gonna have to go up and
Sorry, if you guys could try to not block the TV.
Sorry.
I can't read the TV screen.
No, we're gonna go
Oh, okay.
right next to you.
Actually, oh, of course this thing wouldn't zoom in.
Yeah, it's like.
Go to view. No, that.
Good idea.
F8.
Okay.
Holy crap, how did I just maximize the screen?
What?
Oh, that's
No,
nice.
that's
There we go.
I'm still standing.
I'm gonna get back down.
Okay. Yeah, you have more space now.
Sorry about that.
It's okay.
Okay, so you see that this guy right here is the module name that you're looking at, that you're going to be using. This right here is your the name of the instance, since you can have multiple of the same module. And then we put in our inputs. Now if you remember, the inputs go A, B, C, carry in, R, carry out. So since this is the first bit, the least significant bit, or crap. This is the wrong way. Let me see here what I did here.
0.
So 15 is the most significant bit, right? That's how we set it. So this guy needs to be. No, he does need to be that.
Okay.
Yeah, least significant bit adding from right to left. So we're good there. So we put in the least significant bit of A, least significant bit of B, and the carry-in. Now, the output needs to be the least significant bit of R. But for the carryout, we're going to need a temporary value, right? A quick way of doing that is up here, just declare a wire temp, and we're going to need 15 bytes. We won't need 16. Okay, and that's if you think of it in terms of a circuit, a wire is just a wire.
Yeah.
It's just a random variable, I guess, if you really want to think of it that way,
Yeah.
that you're using.
Okay, fine.
How many times are we gonna do this?
16.
Okay.
Copy and freaking paste.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
We're gonna go back and change all the CIs too.
You want me to see you?
Well, everything. You're going to have to change the numbers on everything.
Oh, yeah.
This is the painful part about it. But really, this is the only...
I'd rather do this in schematics, I think. Maybe.
Yes,
You-
this is
you do.
mindless. It's okay.
You just need to be fast typing.
That would take some type this into the Python program.
Yep, but you couldn't put it on an FPGA.
Close enough.
Plus, everyone knows Python sucks.
Sucks. How did
Yeah.
you change the carrying to temp?
Because the carry-in from the carry-out from the one before needs to go to the carry-in of the other, right? So that's why. You see, if you look at the first two,
Oh, it goes from temp to temp. Okay.
I'm
Yep.
copying and pasting.
I just haven't gotten around to getting the carry-out wired up yet.
Okay.
Oh, the carry-out, that's right. Oh my gosh.
Oh my gosh, the only thing running through your head at this point.
Yep. This is the mindless part.
Nose goes in the mindless part of the program. You got
This is actually this is probably the worst part about
He also has one
everything.
more.
Yeah.
You only have 15. You have
Two.
16.
So, yeah, we should probably make this guy go to 15,
Hey, Dave,
just so...
Yeah, this,
if we put tabs in this to make the
That
variables
number-
line up, will it
this
destroy anything?
you need an
Hit tabs? Oh, no,
No, so,
it shouldn't.
so make it line up to make the numbers easier.
That's the one thing that it actually does good, is that it doesn't worry about tabs, unlike some languages. Oh, never mind. Temp 15's carryout. Duh. Duh.
It's okay. It's been a while. I think.
I'm not going to make test benches for everything. I'll leave that up to you for you guys to test.
Okay.
Especially since I'm actually using the code that I use in my processor. So I know that it should work.
So you can actually like, use this in our processor because this is like the 16-bit ALU right here. Then.
This is the 16-bit ALU.
So
I'm trying to do the ones.
we
I'm
just
trying.
made an LEU in like less than half the time it took us to make a 4-bit.
Well, we have a 16-bit adder now.
Oh wait, that's an adder, not an LEU.
Right.
The ALU will not be much harder at all. And the ALUs where you guys are gonna have to do work on your own. I mean, obviously you're gonna have different opcodes, different capabilities, that kind of thing.
Yeah.
But I can give you like a general overview of how an ALU would look. But yeah, at this point you have a 16-bit adder,
Just like that.
just like that.
Copy and paste 16 times or 15 times.
Exactly.
We confused Yoder today a lot, by the way, of having the
Oh my
very
gosh.
codes.
It was great.
So we had to change it up a little bit. He's like, wait, you have 4 bits there and you have 5 bits there. I don't think that works.
that doesn't make 32.
And we're like, yeah.
Wait a minute. I thought you guys were doing variable registers.
Well, we ended up changing a little bit just to make it easier because we realized what are the semantics of our itype with just one register and the instruction. So
So you did variable opcodes and
as well.
oh, as well. Oh my god.
Blew his mind. He's like, what's going on? I'm like, okay, we got
I love you guys.
Yes! Nothing else matters.
I can die now.
So are you up to date?
He also
Can't
cares
get
about
sick.
everything.
Okay, I'm gonna actually make sure this guy synthesizes. That's generally, if you can synthesize, then it works.
I don't understand why
Wait, so are you synthesizing on what view?
Oh, this is add. No? Okay, why don't you like this, dude?
Why is it Dave?
Oh!
There's something pink.
You can't redeclare the same thing. Just like in programming.
Oh gosh, add 1, add 2,
0.
3. Oh wait, I should do add 0.
55s.
0,
Oh boy. Yeah. How many of these do I have to do, Dave? I will write this Python program.
I'll get done before you do.
like writing a program or?
This is actually the most mindless part. I promise you. Like, there's other stuff that's kind of mindless, but you still need to look at your design diagrams